Unit 6B is where you're finally going to take all the information that you've learned about temperature, humidity, air pressure, and wind, and apply it to the weather. We're going to look at weather maps and make forecasts, and finally apply all that we've learned to the things that we're frequently curious about. Here are the Unit B learning outcomes. Go ahead and pause the video and write them down. This learning video focuses on the concept of air masses. Air masses are bodies of air. They're not really something you can see. They're very large. They form over certain regions and then eventually they mobilize. So these are large bodies of air, maybe 1,000 miles or more across. They can be several kilometers thick, and they have a similar temperature within them at a given altitude, because near the Earth's surface they're going to be a little warmer and they're going to get colder as you go up. They're also going to have a similar moisture content at any given altitude. They move eventually, and as they move, they affect various portions of continents, or as they move over the oceans, various portions of the ocean. Here's an example of an air mass, and this one is forming over Canada. And as it sits there and forms, it develops the temperature and humidity conditions where it is forming. So it's cold because it is very far from the equator, and this happens to be a wintertime air mass. And it's also dry because it's forming mostly over the continent. It's not out here or here over the ocean. There's not a lot of water vapor in this air. So it's cold and it's dry. Eventually, probably from movement in the jet stream, which is a higher airflow, it is pushed and moved down towards the south and the east, but mostly in this picture to the south. And what you can see happens is that the temperatures, even though they warm up as they move south, are still very cold. For example, Dallas and Houston in Texas are below freezing, and that's kind of unusual for Texas. Here are a number of air masses that affect North America, and this is the winter pattern. I'll show you after this slide the summer pattern. And you can see a number of different air masses. Some of them are forming over the oceans, in which case they're humid, and some are forming over the continents, in which case they are dry. Temperature is also indicated based on how close they are to the equator. These that are down towards the equator are warm, and as you go further north, they're cold or even very cold. There's a system to naming air masses that I'd like you to learn, and it goes something like this. First, they're all consisting of two letters, a lowercase letter and an uppercase letter. The lowercase letter is either an M, which stands for maritime, but think of it as humid. That's what it's telling you. Or a lowercase c, which means continental, but that's really telling you dry. So if an air mass forms over land, it has a little c because it's dry. If an air mass forms over the ocean, it has a little m because it's picking up moisture from the ocean. The second letter in the air mass name is a capital letter, and usually it's either a P for polar, which means cold, or a capital T for tropical, which means hot or warm. And so you can see that near the top of the diagram here, far from the equator, we have P's, and then closer to the equator we have T's. And so the various combinations are with a small letter and a capital letter. So you can have four combinations. You can have CP, CT, which we don't actually have on this particular figure, MT, and MP. Now you'll notice there's also this CA, and A is not very common. It's extremely cold air, and this only happens in the wintertime and only in regions where continents are very close to the poles. So even though this is shown here, this is not one of the more common ones. These air masses move in the direction the arrows are showing, and when they bump into each other, that's what's called frontal weather. Cold fronts and warm fronts, as well as occluded fronts and stationary fronts, form when air masses bump into each other. If you happen to be living in the middle of an air mass when it isn't moving, That's called air mass weather, and your weather is rather stable. It's a certain temperature, a certain humidity, and there's not much changing. But if you happen to live, let's say down here, where a continental polar and a maritime tropical air mass are colliding, then you're going to be at a region where there's frontal weather, and that's going to be a lot more exciting because one of those two air masses is going to get pushed upward. And remember that rising air cools, condenses, forms clouds, and forms rain. And frontal weather is what we'll look at in the next learning video. Here's that same area, North America, and this is the summer pattern. We still have continental polar air coming from the northern part of the continent and maritime polar air coming from the oceans. We still have maritime tropical air coming from down here, but now we have this new little area of continental tropical, which we didn't have in the last one. Again, where these collide and meet is where we have frontal weather. Of course, in other parts of the world, there are other examples. One that affects us in Los Angeles here originates out here in Asia. Out here on the continent, they get cold, dry air, and when that air mobilizes, it moves to the east. Because of the way the Earth rotates, the weather tends to move from west to east. As it starts to move over the Pacific Ocean, it becomes less dry because it starts to pick up moisture, and it becomes a bit warmer because it's moving to the south. As it continues, it becomes even less cool and even more moist, and eventually it can hit us with a lot of rather warm air that is very, very humid. Sometimes these are called the Pineapple Express air masses, and they bring a huge amount of rain all the way from Asia to the Los Angeles area. These air masses don't just bring rain. In the wintertime, they bring snow. Here's a great example of how air masses pick up moisture as they go over a water body. This is a much smaller example. This is where air masses travel over the Great Lakes that surround Michigan. Here's a picture of Michigan and the 5 Great Lakes around it, and the colors are indicating average snowfall in centimeters or inches. Pick your units. And again, the weather comes from west to east. And what you'll notice is on the eastern side of these lakes is where the greatest snowfall is. And that's because the weather comes in, as it goes over the lakes, it picks up more moisture, and it dumps additional snow on the eastern side. In fact, you might have heard of snowstorms in Buffalo, New York. It's one of the snowiest places in the United States. I grew up in a place right about here called Muskegon, Michigan, and we got a lot of snow days, which means school was canceled. You often had to shovel not just your driveway, but your roof as well. Low pressure systems in winter still meant counterclockwise rotations of air, but this time those low pressures didn't bring rain, but blizzard conditions. So our next learning video will look at where these air masses collide and cause weather fronts.